Hello, I'm Ellen Liang. This is for the College of Graduate Health Sciences, the course Community Health Informatics. So today I'll be talking about data visualization. I'll be using the GHDX tool. And so first let's look at my data set. So here we have the highest mortality rate and lowest mortality rate of infectious diseases in the country in the year of 2014. And this breaks it down by, like I said before, the highest mortality rate and lowest mortality rate, as well as counties with the largest increase and largest decrease in the mortality rate. And it splits it up by the type of infectious disease. So there's tuberculosis, HIV, AIDS, diarrheal disease, lower respiratory infections, meningitis, hepatitis. So just quickly skimming through this raw data, you could see that there's certain counties that's been listed several times. For example, in counties with the highest mortality rate within all these different types of diseases, you see places like South Dakota, North Dakota appearing several times, Mississippi, see Ohio, Mississippi again here, South Dakota. And so just skimming from the raw data, if you look at with each disease, so for example, tuberculosis, you see North and South Dakota here several times. And then in different diseases, for example, diarrheal diseases, you see two different counties, but both in Rhode Island. Just skimming through the data, that makes sense because for infectious diseases, they're communicable, and it makes sense for counties with the highest mortality rate to be grouped geographically in the same area. With this raw data, it's easier if there's a smaller sample size or just smaller amounts of data, so you could really organize it in your heads. For example, this data set that I have here, it's relatively small. There's 10 highest mortality rate counties, and then 10 counties with the lowest mortality rate, and etc. in each of these different diseases. So it's relatively easy to organize in your head and make a sense of certain trends. But if there were larger sets of data, for example, right here, like just even looking through it, like there's no way I could really get a sense of trends. I could maybe organize, for example, here, change in mortality rate. I might be able to organize by the ranking. So this would organize by increasing in numbers, and I'd be able to see the counties with the highest change versus the lowest change, and then maybe look at it geographically and see if there are any patterns. But again, like I said, it's really difficult when you have a huge data set, and if you're looking at something not local but maybe like national, it is very difficult to deal with raw data. For something simple like what I chose, you could do some like data analysis, maybe like a t-test, and compare the different categories. As well as raw data, you don't really have a context of what's going on. So for this kind of data, I would really like to know geographically, the geographic context of these diseases, and see if they were grouped somewhere. That'd be very helpful, and that's where data visualization can really help in terms of these communicable diseases and studying the epidemiology of it. So here I have pulled up the U.S. health map for GHDX. So what I did was I kept down mortality rate because that's what I'm looking for, and causes I changed it to one of the communicable disease options. So I chose diarrhea, lower respiratory, and other common communicable diseases. So here we see, and I just kept it at age standardized. And so this gives a little more information about the grouping of the diseases. So if you expect that there's no other factors, you would see that these more dense areas with higher mortality rates would be spread across the nation. But you could see here, like there's some with like really high mortality counties with high mortality rates, or clustered around like other counties that also have high mortality rates, not as high. So example, like here, red's the highest, and the orange and yellow are also high, but not as high. So here you see some grouping, and this could be information for us because we can look into that area and see what's different about that area compared to others. So this is really helpful because not only could I see maybe like geographic context, but I could also hover over the county that I want to look at. For example, this Cherokee County, which has 85.23 deaths per 100,000 population. I could look at that, and now that I have the information I need, the county name, I could look more into it. Or like here, could hover around here in Louisiana, the different counties here with high mortality rates of all these different infectious diseases. And it's really helpful here. You get to adjust this. So let's start from 2000. You could play and look at the trend over the years of how infectious diseases have changed in terms of maybe where the highest mortality rates are congregated, or maybe just new areas that's popped up. You could kind of see that as the years went by, you had more mortality, and you can still see the geographical grouping of where counties are with the higher mortality rates. So in comparison of the visualization of the data versus raw data, I think it's more helpful to have a visualization, especially if you're looking at national data. Geographic context could really help in analyzing things, and other visualizations like seeing the trends across a period of time, that could be really helpful in terms of progression. Has the mortality rate been increasing or decreasing? It's a lot faster compared to if you were just looking at the raw data here. You'd have to look back and forth, and here I only have year 2013, so I can't really trend things very well. And so in terms of my analysis of data visualization versus raw data, I would say that raw data could sometimes be helpful, but more helpful if you end up using some data analysis method, like using different tests. But the visualization really helps in terms of pinpointing maybe what you want to look at.